So this question says, the matrix shows the result of a Pee Wee League football season. Pee Wee Football League with results. We got red, blue, green, and yellow. And then we can see their win-loss record. So let's see what we're asked for here. How many more football games did the red team, that's these guys, red team, how many more football games did the red team lose? So we're looking at their losses. Then the yellow team over the 2-year period. So here's the yellow team, and they have lost only 3 games. The red team lost 5 the first year, 9 the second, for a total of 14. So if the question says how many more games did the red team lose, well, 14 minus 3 is 11. So as we take a look at this, I want you to know there is a way to add matrices in your calculator. But on this particular one, it's probably going to show even easier just to do these. So it says each entry in the matrix represents a different doctor's office. The number tells you how many patients visited during the morning and afternoon hours at each of the different offices. So we have morning and afternoon at the different offices. They should all be represented in the same place. Which matrix represents the total number of patients visited each office the whole day? So when we add matrix, they just add up and change their location. So if you were to describe that one, you would call it the left corner. So we are adding these two numbers. So 3 plus 0 will be the new left corner of our solution matrix. Well, both of these have a 3 in the corner. So I can remove these two because they do not. Next thing I'm going to look at, instead of going through here and doing all of these numbers, they clearly both match at 13. They both match at 7. I mean, you could sit here and do that math in your head and double check. But what makes more sense is to recognize where they differ. And the only place I see these two differing is the center piece, and that's the one in the middle and the one to the right. So let's see which one it is. We have 0 here, plus 1 there. 0 plus 1 is 1. This one says it should be 0, so it's wrong. But just to check my answer, 8 and 9 should equal 17. So our correct answer here would be this matrix right there. So as we take a look at this, it says Big Al's used car took an inventory of cars and trucks. That's the two things we're comparing. Cars and trucks. On the lots in January of this year. 77 were cars, 37 were Fords, 19 were Chevys, 21 were Toyotas, and 34 were trucks. So we have description of two things, cars and trucks. Well, if there's only two, we have to know that this has to be the rows, because we couldn't call this cars and this trucks, because then we have a third column that we don't have anything to match up. So it's obviously north south. Now we don't have to necessarily make the cars the top and the trucks the bottom. We just have to make these things match. So the first thing I'm going to do is look at the very first thing. It says 77 cars, 37 of them were Fords. So I'm going to see where we put all of the 37s. Well, 37 here, 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 and here. Right now, this could actually be any of these matrices. Could be any of them. But we do know in this matrix, they have the cars in the top. This matrix, they have them in the top. This matrix, they have them in the top, bottom. And this one, they have in the top. There's nothing wrong with putting these in the bottom. The data just has to correlate. So we'll keep looking. It says 19 were Chevys. So 19 needs to be in the same row as each of these. I see a 19 in this row. I see a 19 in this. I do not see a 19 in this one, which makes it wrong. I do not see a 19 in this row, which makes it wrong. So let's talk about what these all mean. These two are left. This one is saying the Fords are the first column. This one is saying the Fords are the third column. This one, Chevy was the next thing we looked at, is saying Chevys are the second column, and this one says Chevys are as well. Now, the next part, it says, and 21 Toyotas. Well, if we look at this matrix down here at the bottom, here's the 21, here's the 21 here. Well, this can't be right because we just assigned this column a Chevy column. And we were just told that this was a Toyota, so this one has to be wrong. If you wanted to go through and check all of these, you could. We're calling that the Toyota row. So as we move to the truck section, let's see if these all match. 34 of them. You added these up, that would be 34. That's a good sign. 11 Fords. Well, there's my Ford trucks. Yep, that matches. My Chevy, 8, 8. And then lastly, Toyota, 15, Toyota 15. So this is a solution to the represented matrix. Okay, as we take a look at this, the first paragraph is just telling you how to use your correct typing into these, but we're going to jump straight into the answer. And it says a projectile is thrown into the air. The equation negative 3x squared minus 12x plus 96 is the path of the projectile. By the way, this is not on Earth because everything on Earth falls at this rate, but I digress. That's not what the question asks. Let's go ahead and do this. I'm going to obviously start this by putting it in my calculator and just taking a look. It says the x represents the amount of time. Obviously, time is always x if it's part of the equation. It says how long is the projectile in the air in seconds. I'm going to just double check that my data was given to me in seconds, because you got to be careful. Sometimes they'll say in 10 seconds, minutes, but it does say time is in seconds. So when I graph this thing and I look at the table, here's the table I see. 096, 181. Let's talk about what this means. After 0 seconds, the projectile's at 96. Well, that means it was shot from an elevation in the first place. So after 1 second, it's at 81. After 2 seconds, it's at 60 feet. At 3 seconds, it's at 33. And at 4 seconds, it's at 0. And remember, y represented the projectile's height. So when the question asks, how long was the projectile in the air? Well, it's back on the ground, 0, after 4 seconds. So the answer to this is 4 seconds. A lot of you did really good on the test yesterday, graphing and recognizing that very thing. Good job. Okay, first things first on this question. I hope some of you do problem-solving tactics on this. Strategy is always a good way to look at these. I'm going to work these out by creating equations, but remember what you're searching for on these things. A lot of times you can come across the answers you need. Now it says dog food sells for, I usually like to actually start these reading the last sentence because it's going to tell me what my variables are. It says how many pounds of, here they come, high protein blends are needed to produce 50 pounds of mix. Usually it'll tell me the other ones, but clearly one is high protein. So let's see what else we have. It says dog food sells for 50 cents per pound to be mixed with a high protein blend for $1.50 a pound. So apparently our two variables are a regular protein and then a high protein. Doesn't specifically say this, so if you wanted to call one the other one Y and this one X, that's fine. You're good either way. So here's what it says. A dog food sells for 50 cents per pound. Per means multiplication. With this, it's 50 cents per pound of the regular, so that would be X. And then it says to be mixed with a high protein. Mix means we're going to add these two together, which sells for $1.50 per, meaning multiplication, pound. Well, the high protein, we were using the Y. So that's what we have so far. It says how many pounds of the high protein blend are needed to produce 50 pounds of mixture for a price of $1.25 per pound. Well, let's think about this real fast. Anytime you're writing these, most of the time what you're going to do is create a how much and how many. All right, how much and how many, think of it this way. So I'm working on the how much equation right here. How much money is it going to cost? So let's talk about the how many. Well, it says we have 50 pounds of mix. Well, that's our how much we have. Excuse me, how many pounds we have. So that's 50 pounds. And 50 pounds is made up of the regular mix plus whatever we have of the high protein mix. Now, this is the part where I was saying you could use some common sense. You know, whatever one is, the other one adds up to 40. For instance, this one is saying, the question was how much high protein? So 25 pounds of high protein means that there would be 25 pounds of regular. This one says 40 pounds of high protein, which would have left 10 for regular. This one says 37 and a half, which means, you know, what, 12 and a half, and this one is 62 and a half. Well, it can't be that. How could we have 62 pounds of high protein when we only have 50 pounds in the mix? So that was not even close. All right, so let's use common sense real quick. The regular protein is 50 cents a pound. The high protein is $1.50. Once the mix was made, whatever it was, the price ended up being $1.25. Well, think about this. If it was perfectly down the middle, 50-50, it would be $1 each because that's 50 cents from the low, 50 cents from the top. But since this is closer to 150 than it is to 50 cents, that means more of the high protein was used than the low protein. So this answer can't be right. That one says equal amount. If there were equal amount, it'd be $1 a piece. All right, back to our equation though. So on our equation, the how much is it going to cost goes here. It's 50 cents times the number of regular protein, $1.50 times the high protein, and this all needs to equal $1.25. And what we would say here is normally X plus Y, the total amount. But they told us the total amount. It is not a variable. It is 50. So this is our equation right there. I'm going to go ahead and write this below because this is a number. So we're going to write this below. I'm going to remove this for just a moment because it's going to be in my way. But I'm going to just take this down and move it below after my change here, which is 0.5 x plus 1.5 y equals 1.25 times 50 is 62.5. All right, now what we need now is for these equations to either eliminate, you can use substitution, graphing would be a little tougher, you could even make a matrix. But what we need is for this to eliminate one of the variables. This is actually not that hard to do when you think about it. What would eliminate a positive 1 in the x? Well, what would eliminate is if the bottom had a negative 1. Well, it's pretty easy to get 1/2 equal to 1. We just have to double it, right? So what I'm going to do is take the entire second part of the equation, and I'm going to double it. So I'm going to multiply this times 2. Now, if I do that, though, I'm going to have x1 on top and x1 on bottom. I don't want them to be the same. I want them to be opposite. So I'm going to drop a negative sign in here. And what I'm going to do is distribute this -1 to everything. -2, excuse me. -2 times, I'm going to write this in a different color. -2 times 1/2 is -1x. -2 times 1.5 is 3. And -2 times 62.5 is -125. So I multiplied to make everything eliminate there. Now I'm going to remove this, and now we're going to do the elimination method. Here's why I did this. x1 eliminates -x1. The y minus 3y is -2y. And 125, -125, plus 50 is -275. Running out of space here. And then the last thing we need to do to get y by itself is divide by -2. Y would equal 37.5. I really think that this one probably would have went faster if you just plugged in the values and saw. But this is the way we do it algebraically. This is another one that's just going to go straight into the matrix for me. This is a 3x4 matrix. These are a nuisance when you try to do these by hand, but they're not too bad with a calculator. So what I'm going to do, make a bigger matrix, is plug these values in. It says customer one, buys 3 apples, 2 oranges, 1 pear, and it was $8.50. Customer 2, 2 apples, 1 orange, 2 pears, $7.50. And the last one, 1 apple, 2 oranges, and 3 pears, $9.50. So I'm going to go to my calculator and type these in. I'm going to just say this, and I'm going to give you a solution matrix. So what I do is I go second, matrix, and I'm going to hit the right arrow key twice and go over to edit. Now I hit edit, and it's going to ask me my matrix size. This is a 3x4 matrix. And I'm going to input the values starting from here, moving this way. All I got to do is hit enter. So I hit 3, enter, 2, enter, 1, enter, and then 8.5, enter. Then I do 2, enter, 1, enter, 2, and 7.5. And lastly, 1, enter 2, enter 3, enter 9.5. So now I have all the data put into my calculator. Now I got to tell my calculator what to do. I'm going to hit second quit to go back to the home screen. Under this, I'm going to hit set second matrix again, the right arrow key one time under math, and I'm going to look for my good friend RREF. On my calculator, it is option, sorry, passed right by it. My calculator, it is option capital B. So I picked RREF. So once I've hit RREF, I'm going to hit second matrix for the last time. Now I called my matrix A, so I just have to hit enter. So now my screen says RREF, and it's got a parentheses, and I'm going to put in my matrix, sorry, parentheses, and I'm going to put in matrix A. When I do that, I get a table that looks like this. First parts are great. Whoops. This is just my calculator's way of saying, yay, we got it right. That is the identity matrix. And then the value on the outside go here. 1.25, 1.5, and 1.75. So what this is saying is, hey, your first variable was $1.25. Well, that does happen to be apples. This means the second variable you chose, well, the second variable we chose was oranges, are $1.50. And then lastly, your third variable, which we chose to be pears, $1.75. Matrix is just the best way to do these systems, especially these 3x4s. Okay, so let's take a look at this and see. It says Chelsea can choose from 2 plans for streaming videos by her television. Plan A costs $19.95 initially and charges $1 per video. So it's got an initial charge just under 20 bucks, but $1 a video. Plan B has no initial charge, but it charges $3.50 per video. Use the equations, the equation for each plane or graph in the coordinate below based on the graph. What is the minimum number of videos Chelsea should stream so that plan A is less than B? So we're basically looking for our intersection here. So Chelsea should stream so that plan A is less. Well, A is this one right here in green. Plan B, the no charge, but initial fee, but it's going this way. And again, based on the graph, what is the minimum number of videos Chelsea should stream so that plan A is less than plan B? Well, we can see that it doesn't get less than plan B until between 7 and 8. Well, 7 is not quite big enough. 8 is too big, but that's okay because it says should stream so that the cost is less. It's not less at 7, but it is less at 8, so that's our correct answer. It says which statement of the function below is true? Well, the function has a minimum value of -3. Well, -1, 2, 3, clearly this goes well below that, so that is nothing. Remember, the minimum is the y values. X is left and right. It says the function has a minimum value of -6. -1, 2, 3, 4, 5, 6. Looks like it's got some promise there. Let's see if we got a better answer. The function is decreasing, meaning going down, not below, but it's going down in intervals from -5 to -1. -1, 2, 3, 4, 5. Okay. From here to -1, it's telling me that it is decreasing. No, those are consistent. Even though it trended down, it trended back up. So this one's definitely not right. It says the function is symmetric across the value y equals -3. -1, 2, 3. So this is symmetric across the value -3. Oh, I see what's wrong with B. Been talking about this all day and then I overlooked it. Hopefully you can see it as well. It says the function has a minimum value. Oh, no, when x is equal to -6. That is not the x value, that's the y value. So that's wrong. All right, so let's take a look at this one. It says Stella starts from baseball stadium, excuse me, and bikes home. The table shows the relationship between the minutes spent. That's important. We like to highlight important things. The minutes spent biking and the distance in miles left to cover. So you can clearly see no time spent biking. She's 6 miles away from her destination. We also take a look and we see, okay, when is her distance 0? That would be at 45 minutes. So she's clearly a 45-minute ride away. So let's check our stuff out though. It says the x-intercept 6. The x-intercept is 6. Sorry about that. And it represents the distance remaining in miles between Stella's house and the stadium. Well, that's not what we have here because minutes is our x value. So this would be the y-intercept, not the x-intercept. So that answer's wrong. Next one, it says the x-intercept is 6. Well, the x-intercept is when y is equal to 0. Or excuse me, when y is equal to 0. That's right here. So the x-intercept was 45 minutes. So that's no good. All right, the y-intercept is 6. Remember, the y-intercept is when x is equal to 0, so that checks out. And it represents the distance remaining in miles between Stella's home and the baseball field. All right, so let's keep reading the next one. And the next one says, because that one could be true, the y-intercept is 6, which we just established. And it represents the distance in miles Stella biked each minute. Well, no, that's not the case. We're not talking about her rate. We would have to computate that. So the y-intercept is 6. It represents the distance remaining in miles between Stella's home and the baseball stadium. Makes perfect sense. All right, it says the company finds another website with free shipping. Speedy Printing, that offers a rate on mugs and pens that vary by the number of items purchased. Each graph displays the cost of the pens. Our job is to select true or false for each of the statement below. Let's see what we got. It says if the company buys 10 pens, that's the part across the bottom. If the company buys 10 pens, the cost of the pens is $6. Doesn't say each, it just says the cost of, I'm sorry, that's right. The cost of pens is $6. Well, if we had 10 pens and the cost of each pen was $6, that means our output would be $60. We can see that we have an open circle, meaning that is not part of the solution set, that this part's going to be false. It says the company buys 25 pens, so we go find 25. There it is. the cost is 4 cents. Well, if it's 25 cents per pen, or excuse me, they bought 25 pens and they're $4 a piece, that should be a total of 100. Let's see. Oh, that checks out. So this is a true statement. If the company buys 30 pens, well, here's 30 pens. Cost will be $4. Well, 30 times 4 would be 120. But remember, that is an open circle. Open circles are not part of the solution set, so this would be a false statement. And then the last one. If the company buys 40 pens, there's 40. The cost of pens is $2. Well, let's track it up here and see. If I bought 40 pens, I bought every one of them. $2 a pen times 40 would be, in fact, 80.